Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. Me, Muhammad NAJWAN bin ASRI and our teammate, which is FARHAN, HAZIQ and HAFIZ, will present our task, which is make a video about application of differentiation. I will explain about the differentiation. Differentiation in mathematics process of finding the derivative of rate of change of a function, in contrast to the abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulation, using three basic derivatives, four rules of operation, and a knowledge of how to manipulate function. Next, why we use differentiation in our daily life. Differentiation allows us to find rates of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration in physics. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. There are a number of simple rules which can be used to allow us to differentiate many functions easily.
The topic that we have chosen in relation to rates that use differentiations is related rates. In differential calculus, related rates is a problem involving finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. And the method to solve this question is firstly to find the equations that relate to the two quantities. And the next is to use chain rule or implicit differentiation to differentiate both sides with respect to time.
So how do we solve this problem? So the first step is define the stated object. For example, cone or sphere, and draw the figure if necessary. Step 2 is identify the rate of change from the given information. So if the information gave state that it is increasing, so the answer will be positive, and if it is decreasing, the answer will be negative. So for step 3, we need to determine the formula or equations that related to quantities or variables of the problem. And step 4, we differentiate the equation with respect to time by using chain rule or implicit differentiation. And step 5, we substitute the given numerical value and solve for unknown.
Okay, the following is the best example of the question related to red cone. So let me read the question first. A conical water tank with vertex down has a radius of 20 meter at the top and is 34 meter high. If water flows out at the tank at the rate of 30 meter cube, meaning -1, how fast is the depth of the water decreasing when the water is 26 meter depth? So, as we can see here, the first one, the shape is already a cone. So we can take that as a note. And the second one, when we are reading the question, we already can saw that uh the dv over dt, which mean the 30 meter cube mean -1 is negative because it is decreasing. So from the above information, we can already remove some of them. So as example is r equal to 20 meter. This is about the radius equal to 20 meter. And for the height is 34 meter. So as we say just now, dv over dt is equal to -30 meter cube mean -1. So the real question is when h equal to 26 meter, what is actually dh over dt? So when we are looking for this solution, we can just imagine this stuff. So we can already guess this is actually a chain rule. So we can assume that dH over dt equal to dH over something multiplied by something over dt. But what is actually in the box? So the thing that at the box is actually is dV, because we can refer to the dV over dt, the information that we just get at the question. So we can proceed to the our solution. So the first one, you are going to use the radius over height is equal to 20 over 34. So why we are using R as a main, not even H? Because the question that we want to use, we need to have dH over dV. So that's why we are using R as a main instead of H. So we are going to, when we get the R is equal to 10 over 17 multiplied by H, we can just set it at the volume. V equal to 1 over 3 pi R squared H. This is the volume for the cone. So 1 over 3 pi 10 over 17 H squared H. And the final answer is 100 over 867 pi H cube. So we can conclude it as dV over dH equal to 100 over 289 pi H cube, pi H squared. Next. So after we got all of the information, we got dH over dt, we got dV over dt. So we are going to refer for the real question. What is it about dH over dt when H equal to 26? So it's actually simple. We already got all of the information. We just put it at the equation. So dH over dV is 289 over 100 pi. So the R we are going the H we are going to replace with the 26, and we are going to multiply by dV over dt negative 30. And so the final answer we got negative 0.04082. So this at the right, this is just a note that we are used, because the statement says that uh the liquid is flows out. That's why we are going to put negative, because it is decreasing. But if it's in a positive way, it means that flows in and it is increasing. Okay.
Okay. In conclusion, related rates, or rather differentiation, is used in many fields, and it is practical and helpful in our daily life. Through related rates, we can find the values that would otherwise be unknown through series of differentiation and mathematical equations. And for example, from the question, we found the rate that which water escapes the cone, and we can use related rates for many other situations. For example, change of speed over time and acceleration. So uh, we can conclude that related rates is useful in our daily lives.
That's all from us. Thank you.